In the previous video, we walked through exploring your problem. Now we're going to get into the meat of refining the problem and working on developing a hypothesis for your analysis. You now know that you don't have direct data on smoke alarm installation in your city, and that instead you're going to be looking for data that will help you predict if a residence will have one installed. So what does it really mean to predict something? To predict means that you are making a statement about the future, about something that might happen. Ultimately, you are guessing, but it's usually a fairly informed guess based on observation. Like analysis, this is something we do all the time. If your teenager doesn't get to go to the party they want, you'd likely predict they will have a meltdown. Or if rain is followed quickly by sun, that would produce a rainbow. Humans are prediction machines. Over your lifetime, you've been collecting data about these kinds of events, and you've built up what people call a model, in this case a conceptual model, about how the world works. In the context of your project, what you want to do now is be very explicit about building your own model of what might help you predict smoke alarm installation. What you need now is a hypothesis. You've probably heard the term hypothesis already. It's very similar to a prediction in that it's an educated guess, but a hypothesis is ultimately something that you can support with data. You'll often encounter hypotheses in the context of conditional statements. If some condition, then some outcome. For your project, you need to find those conditions that are more likely to be associated with homes containing smoke detectors. You'll then use data analysis to inform how confident you are about that prediction. This is a way of approaching a problem that is called deductive reasoning, and we'll take a closer look at that next. Deductive reasoning moves from the general to the specific, while inductive reasoning moves from specific examples to a generalized conclusion. Deduction starts with a theory, generates a hypothesis, and uses observation, and often data, to confirm the theory. In deductive reasoning, if something is true of a class of things in general, it is also true for all members of that class. That means deductive conclusions are certain provided the premises are true. Whereas induction starts with observation, looks for patterns, then creates a tentative hypothesis from which a theory emerges. Even if all of the premises are true in a statement, inductive reasoning allows for the conclusion to be false. That said, inductive reasoning has its place in analysis. You can use it to form hypotheses and theories. And then deductive reasoning allows you to apply those theories to specific situations. Your team decides to have a brainstorming session to come up with building conditions that could potentially be related to whether smoke alarms are installed, which is an example of inductive reasoning. Excuse me. From there, you can work on some potential theories and go get some data to test them. Get out that paper again and write down some conditions of buildings that might be related to whether they have a smoke alarm installed or not.